I don't ever slow up, no I don't take sh**. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take sh**. I got no love for the fakeness.
We're starting with industrial electronics. This is industrial electronics N4. Right? So we're going to start with topic 1, which is DC current, direct current theory. Now, under direct current theory, still remember what we did in N1, N2, N3, right? Where we had to calculate current, power, voltage, and stuff like that in seconds. Now, it's going to be the exact same thing. But then this time, we're not going to use Ohm's law. Yeah. The last time we were using Ohm's law. This time we're going to use 3 laws that I need you to know with your heart. First of all, we're going to start by using Kirchhoff's. I don't know if that's the correct spelling for Kirchhoff's. We're going to start with Kirchhoff's laws, right? And then secondly, we're going to do superposition. Superposition theorem. And then after this, we're going to focus on the nice one, which is Thevenin. Are we together? Yes. Which is Thevenin. Now these are the circuits that we're going to focus on. And from N3, N2, N1, we only did circuits with only 1 battery. Now this time around, we're going to do circuits with 2 power units. Are we together? Yes. We are together, sir. Okay, switch. So let's start with Kirchhoff's. I don't know if that's the correct spelling for Kirchhoff's. Kirchhoff's laws. Let's start with the first law. Now this is 3 marks in the final exam. Are we together? This is 3 marks in the final exam. So in the final exam, they will say state Kirchhoff's first law in words. Are we together? Yeah. Or say Kirchhoff's current law. Are we together? But normally they would want you to say first law and second law. Because if they say Kirchhoff's current law, it makes it way easier for you to know which one it is. Or if they say Kirchhoff's voltage law, that makes it very easy. So for Kirchhoff's first law, I need you to understand it by first putting a dot. Are we together? So this is Kirchhoff's first law or Kirchhoff's current law. I know you already know this, right? We say the algebraic sum of currents entering a point is equals to the algebraic sum of currents leaving that point. So if you've got current 1 entering and current 2 entering, and they only have current 3 leaving, right? Current 1, current 2, and current 3. Now this means that current 1 plus current 2 should be equal to current 3. Are we together? Yes. This is known as Kirchhoff's first law. Are we together? Yes. So in words, is the sum of currents entering a point is equals to the sum of currents leaving a point. Or if you want to get more technical, you say is the algebraic sum of currents entering a point is equals to the algebraic sum of currents leaving that point. That's just fancy English. It doesn't mean anything. Let's move on to the second point, to the second law. Now, the second law is also very easy. Yes. The second law is also very easy. The second law says that the voltages or the sum, let's say you've got a resistor, and a resistor there, and then you've got your power supply here. Now, when current passes through a resistor, you've got voltage drop. Are we together?
Yeah, voltage drop because in this series.
Yes. So for every resistor that you have, you've got voltage drop. So for Kirchhoff's second law, it says the algebraic sum of voltages in a current is equals to 0. In a circuit, is equals to 0. Are we together? Okay. Or in other words, it means that whatever that you're putting in is equals to whatever that you're taking out. So if the power supply, which is your battery, VT, is the one that is producing all the current, right? All the voltage. It should be equal to all the voltages that are being used by these 3 resistors. Are we together? So it now means that VT is equals to, let's call this one V1, V2, and V3. Is equals to V1 plus V2 plus V3. Because this is applying and these are using. Are we together? So is the algebraic sum of voltages in a circuit is always equal to 0. Are we together? Okay, so let's do a few examples. Now we're going to start with what you know, right? Which is mostly revision from N1, N2, and N3. which is one power supply. I mean, which is circuits with only one power source. Are we together? Okay, so let's look for a beautiful circuit in the textbook. Okay, there is a beautiful circuit here. Let me draw it. This one is 24 volts. This one is 8 ohms. This one is 6 ohms, and this one is 12 ohms. This one is I1. Now you should be happy if they give you the names of the currents, right? Mostly they don't give you the names of the currents. They want you to name them yourself all together. So you say this one is I1, this one is I2, and then this one is I1 minus I2. Now what you get? So you've got your I1, you've got your I2, and you've got your I3. They're saying using Kirchhoff's laws, complex quantities can be solved. To explain this, blah, 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 blah. Now, calculate the relevant currents and voltages. Or in other words, they want us to calculate the currents flowing through each branch. Are we together? So we should calculate the current I1, I2, and I1 minus I2. Are we together? That's what we should focus on today. Okay. So the very first thing that you do with Kirchhoff's, right, is we name the circuit. Are we together? We name all our points of the circuit. So let's call this one A, B, C, D, E, and F. Are we together? After we're done naming these circuits, now here's the trick, right? We're going to form loops, right? Now, let's start with, I would prefer you use very, very simple loops. Are we together? And your loops have got very simple rules, right? The first rule of the loop is that it should form a complete circle or a complete loop. Are we together? So that means if your loop starts at A, it should come back to A. Are we together? That's the first rule. You can't have a loop that starts at A and it ends at B. Then it's not a complete loop. And the second rule is, this is the most important rule that many people forget, right? Is if your circuit, if your loop is going in this direction, right? That's the direction of your loop, right? But if you check your currents are going in that direction. This means that the direction of the loop and the direction of the current are opposing each other. If they are opposing each other, you put a negative on your current. Are we together? What does a negative sign mean? Reversal, right? It means opposite direction. That's what negative means. So if your loop is going in the opposite direction of your current, you put a negative. Okay, so let's start. Now we're going to choose whichever loops we want to take then. And I want us to take the easiest loops possible. So let's start with the first one. Let's start from A and then we stop at A. Are we together? So it's going to be loop A. It goes to B, goes to E, goes to F, comes back to A. Are we together? Now this is an example of a complete closed loop. Are we together? You can make three loops with this circuit. Let's do another one here on the side. You can have loop. Let's make this one start from A as well, right? You can have loop A, B, D, E, F, A. Exactly. If you want, you can also have another loop here. Are we together, right? Which is going to start at B, which would be B,
or B,
C,
D, E, B.
B. That is correct. Are we together? Yes. Right? So you can form three loops with this circuit, which is also absolutely perfect. Are we together? There's absolutely nothing wrong with that. Okay, so let's start with this loop. Now, if you decide to form this loop, right, here's also another trick that I want you to know. If you don't have a voltage source in your loop, right, then that means the voltage source is equal to 0. Are we together? Because if you check our law, it says VT, which is the total voltage supply, is equal to all the voltages that are used up. So in this case of this loop here, there is no voltage source, there is no battery here. That means the total voltage supply is equal to 0. Makes sense? Right? Yeah, sweet. Now, in order for you to maximize all the max that you can get, right, you start first by putting in the formula.
Yeah.
But now you're in N4, this does not have many marks in N4. Probably like 3 marks for getting the whole thing, if you're lucky. 2 if they're stingy, but not less than 2. So you start with Vt is equals to V1. So this is your Vt, right?
Yes.
Is equals to V1. So this would be your V1 plus your V2, and then this would be your V2. And then your loop starts back again. Are we together? So after that, we need to expand. Are we together? We need to expand this. So it's going to be Vt is equals to, and how do you calculate the voltage using Ohm's law? Current multiplied by resistance. Are we together? So in this case, it's going to be our current, which is I1, multiplied by the resistance. Are we together? And then in this case, for the second loop, it's also going to be our current, which is I2, multiplied by the resistance. Let's call this one R1 and let's call this one R2, right? Switch. So this is how it's going to go. And then after that, we're going to substitute now. All the symbols that we have, then we substitute them with values. So for Vt, our Vt is 24. 24 is equals to I1 multiplied by R1, which is equals to 8, right? Plus I2 multiplied by R2, which is equals to 6. That is perfect. 6. Now let's do some mathematics. So 24 is equals to 8 I1 plus 6 I2. That's perfect. After this, there's nothing you can do. It's like it's finished after this. So this is going to be equation 1. Now, this is simultaneous equations now, right? Now let's go to the second loop and let's also form a second equation for the second loop. So we're going to do the exact same thing that we did here as well. Okay, so it's going to be Vt is equals to V1 plus V2, right? So this is going to be a V1. Now if you decide you don't want to make things confusing for yourself, right? You can say this one is your V1 and this one is your R1. This one is your V2, this one is your R2, then this one is your V3, this one is your R3, if you want. So this one will now be equal to V3. Are we together? It doesn't really matter because there is no marks awarded for saying V1, V2. The only thing that I want you to do is to have continuity when you're doing your calculations. Are we together? And make sure that your calculations flow. In the final exam, don't do this. This is only reserved for the teacher, which is me, in the board. So in the final exam, don't calculate like this. Make sure all your work goes down. Are we together? Switch. So after that is going to be Vt is equals to V1. V1 remains unchanged, right? Which is I1 multiplied by R1 plus. But for our V3 now, our current is now
I1 minus I2.
I1 minus I2 multiplied by R3. Are we together? Now if we do, this is supposed to be a close bracket. I'm coming from holiday, so my handwriting is,
Kirchhoff, sir?
So our Vt is still 24 is equals to I1 multiplied by R1, which is 8, right? Plus let me open bracket, I1 minus I2 multiplied by R3, which is 12. That is perfect. Right. And then after that, we'll do some mathematics. Now it's going to be 24 is equals to 8 multiplied by I1, you get?
8 I1.
8 I1, that is correct. And let's remove the brackets here, right? I1 multiplied by 12, you get 12 I1.
Yeah.
So let's say 12 I1 plus 8 I1, what do you get?
So it's very confusing. Sometimes I change the change of the sign.
Changing of the sign.
Because of multiplication and that one is negative.
Now don't worry, I forgot my calculator. I wanted to bring, snap. I wanted to bring my calculator, but it's fine. You were saying?
I was saying there, when you're opening up the bracket, sometimes when we are the kids, we getting confused about those subtraction sign and division.
The subtraction signs?
Yeah, and changing this.
Okay. You know what I'll tell you? I'll tell you, don't stress. Don't even think about it. Don't even worry yourself.
To open now when I open.
Yeah, don't even worry yourself. Just relax. Because it's going to happen naturally. You see, it will happen naturally. So you say this one is 8 I1. Right? And then this one, without even thinking of the signs, if you look at I1, your I1 is positive, right? And your I2 is one that is minus I2. So the I2 is one that is negative. So when you're removing the brackets, you multiply this one, multiply by that one. This one, multiply by that one. Then the brackets are gone. Are we together? Okay. So it's going to be 8 I1 plus 12I1, right? That's going to give us 20I1. So this is 20I1 plus, oh sorry, I don't know if it's plus or minus here, so let's leave it as minus. But then we move on to the second one, right? It's now negative I2 multiplied by 12. You get negative 12I2. After this is finished, there's nothing we can do. Because now we have 24 is equals to 20 minus 20I1 minus 12I2. It's finished. Now we've got these two equations that we have side by side, right? Now we need to find the value for I1, the value for I2, and then lastly the value for I1 minus I2. Are we together?
Yes, together.
Okay. Now there are two methods in which you can do simultaneous equations. You've got substitution, right? Which you make the third equation and then you substitute, right? And then you've got elimination, which is where you stack these two up and then you eliminate one. Which one do you prefer? Substitution is making the third equation where we make either I1 subject to the formula or I2 subject to the formula, or elimination where we put equation 1, equation 2, then we subtract them and then we remove the other one.
Most of the time I use substitution.
Use substitution.
Yeah,
Alright, let's do substitution.
Yeah.
Because substitution, I think everybody knows substitution.
Yeah.
Right. So let's take equation 1 and then let's make equation 3 from equation 1. Are we together? And then in this case, just to make things easier, let's make I2 subject of the formula. Are we together?
Yes.
So I2 is equals to, now let's start, is equals to 24, right?
Yes.
The 24 is here.
Yes.
Right? And then if we take I1 to the other side, it becomes
Positive. Negative.
negative. Hey, you give me a heart attack. So it's going to be minus negative I1. Now if you want to remove this 6, you divide both sides by 6. Are we together? So everything is divided by 6. Now let's just make sure that this looks beautiful. Right? So is I2 is equals to 24 divided by 6. What do you get? I am getting 4. Let me double check. I'm a genius. It's 4. Eh?
Divided by 6. Yes.
Hey, I was blessed with godly abilities. Eh?
Wow.
Okay, let's move on from there. Now, if you say 8 divided by 6, what do you get? 1,3333. Oh, I was blessed by the gods. You can trust me.
Yes.
1,333 I1. Now, this is now our equation 3. Are we together?
Yes.
Now, let's substitute our equation 3 into equation 2. Are we together? Now, in order for everything to be neat and nice, remember you've started with this, then you moved on to this, but then this is under this, and this is under this. So your work is flowing perfectly, right? Yeah. Then after you're done with this part, right, I would need you to do the next step is, I want you to write substitute equation 3 into equation 2. Right? Now, don't make this mistake of substituting equation 3 into equation 1, because all your answers are going to be zeros. Right? All your answers will be zeros. So don't substitute equation 3 into equation 1, but substitute equation 3 into equation 2. Are we together? Yeah. Whichever equation that you use to make equation 3, don't substitute into that one. Substitute into the other one. Are we together? Okay. Sweet. So let's start. Equation 2 says 24 is equals to 20 I1 minus 12 I2. But we're saying I2 is equals to 4 minus 1,3333 I1. Are we together? So we're going to open our bracket, and then instead of putting I2, now we are putting 4 minus 1,3333. So 4 minus 1,333 I1. Sweet. You see what I was talking about when removing the brackets as well? Now I don't want you to think about it. Don't. Everything becomes complicated when you think. Just do it. Don't think. Okay. So in this case, it's 24. If we move ahead with the maths, right? So in this case, it's going to be 24 is equals to 20 I1. Now let's remove the brackets now, right? So it's going to be minus 12 multiplied by 4. What do you get? Or you can say minus, because the 12 is the one that is got the minus. So you're going to say 12 multiplied by 4. If you say minus 12 multiplied by 4, you get minus 48, right?
Say a genius.
Minus 48. Oh, I'm a god. I was blessed by God. Minus 48. And then if you move over to the next one, 12 multiplied by 1,333. Now, remember this now. You've got minus and you've got minus. So it's minus 12 minus 1,33. Minus gives you plus. Are we together?
Yes.
So this looks like a times. It's supposed to be a plus. So 12 plus 12 multiplied by 1,33. I can tell you the answer. You know what it is?
No.
Wait, give me 2 seconds. Wait, don't tell me. 4. Yes, I got it. Is it 18? Nah. Wait. Yes, 4, 8. Yes, 18. 18 is my answer. What did you get?
My answer is saying 15,996.
15,99.
Yeah.
So that means it's 16. Oh, yes. The answer is supposed to be 16. Yeah, man, it's me who's getting old. Why am I writing 18 instead of 16? See, my head is stuck. My head gave me a wrong answer.
We are still in December.
I'm still in December. The booze is still in my head. Okay, so let's do some mathematics, right?
Yes.
Now let's do this. Apples to apples and oranges to oranges. Are we together?
Yes.
So let's put all the I ones together and all the numbers together. Right? So if you say 24, take 48 to the other side. It's minus 48. What is it going to become? Plus 48. So you'll have 24 plus 48 is equals to 20I1 plus 16I1. Are we together? Let's move these items to this side. So 24 plus 48, what do you get?
72.
72. That is correct. 72 is equals to 20 plus 16, what do you get? 36.
36, yes.
Right. So this is going to be 36I1. Yeah. Now if you just do that, like some simple mathematics, divide both sides by
36.
So I1 is equals to easy stuff, man.
Yes, sir.
Easy peasy.
It's 2,111.
2,111 amps. That's perfect, right?
Yes, sir.
2,11 amps. Now let's move over and let's calculate I2. Now calculating I2 is going to be the easiest because we already have an equation 3 which has made I2 subject of the formula. Are we together?
Yes.
So in this case, I2 is equals to 4 minus 1,333I1, right? That was the equation.
Yeah.
So now we just substitute I1 for 2,11. Are we together? So it's going to be 4 minus 1.333 multiplied by 2,11. What do you get to answer it?
1,186.
1,186. Now, according to the textbook, this answer is wrong. So let's see what went wrong. Now let's check 72 divided by 36. It's 2 straight.
My mistake.
Yeah, the answer here is 2 straight. So it's just 2 amps, not 2,1. It's not a problem. Okay. That means this is also wrong. So here we multiply by 2. So 1,333 multiplied by 2 minus 4. What do you get? I can't do this one with my head.
Okay. Well, I can start with 4. I can start with saying 1,33 times 2.
What do you get?
Minus 4. I'm getting negative 1,334. I'm wrong.
Can you start again? Start by saying 4 minus 1,333 times 2. Let's see. 1,
334.
let me check the textbook.